Welcome back, everybody. We're moving into Module 8, Chapter 8, and we're going to do this stuff right here. I'm going to download this slide right here, and this is where we're going to begin. I'm going to go to ChatGPT and create a new chat right up there. And if I want a little bit more room on the screen, I guess maybe I need to refresh this. There we go. Let's see if that works. Create a new chat. Oh, I've got a new chat. And I'm going to drag over that presentation, or I'll just do upload from my computer. And it's this one right here. So there it is. I'm going to say, can you please explain to me what is interval estimation? And I could just grab that phrase right there. Interval estimation in statistics. In simple terms, can you please explain to me what is interval estimation in statistics? So this gives you a little bit of context of what's being covered. So in simple terms, interval estimation in statistics is a method used to estimate a range of values that is likely to contain the true value of a population parameter, like the mean or proportion, based on sample data. So we get sample data to make inferences about the population. And our sample data, right, it's a statistic. And it's going to be, the word I'm looking for is it's a point estimator. It's a point estimator. It estimates a point for the population parameter. Okay, so just like get a pen and write these words down. We have a sample, and we get a sample so that we don't have to study the entire population. And with that sample, we make inferences about the population. That's inferential statistics. So sample, population, inferential statistics. You should write those down. Let me just give you a little hand here. I'm going to bring up my notepad, and I'm going to delete that as an email I was writing. And we have a sample, and we have a population. So here are just some words we're learning about. And this is inferential statistics. And we go over things because repetition is the mother of mastery. And practice, ladies and gentlemen, practice leads to progress. I don't know if I can make this bigger. I can. That is so nice. So we have a population, and then with the sample, right, we get a point estimator. And a point estimator is going to estimate the population parameter, right? And so a type of population parameter we might have is like the mean, or we might have proportion. And a proportion might be what proportion of the people have a pink, I don't know, what is this, mauve? Have a mauve cell phone case. What proportion of the people we survey in the population, what proportion, we're learning about the word proportion, what proportion have a red water bottle, And so these are population parameters, and we get a point estimator of these different population parameters. And those point estimators, it might be a point estimator for the mean that we got from the sample that we're using to do inferential statistics so we could gain insight into the population parameter, the mean, right? Or maybe we're doing a proportion, and so we get the point estimator for the proportion from our sample. And using inferential statistics, it's kind of there. I don't know. I feel like statistics, makes things overly complicated with their jargon, but whatever. We can, based upon the point estimator that we got for the proportion by doing our sample, we can make inferences about the population parameter proportion, right? That's it. So that's a vocabulary. In simple terms, interval estimation in statistics is a method used to estimate a range of values that is likely to contain the true value of a population parameter. So estimate a range of values that is likely to contain the population parameter. So we have a new word here, interval estimation. And so interval estimation, I'm going to put this down here, is a method used to estimate a range of values that is likely to contain, we'll take all that, like the mean of proportion based on sample data. That's good. All that is great right there. I like that. So interval estimation estimates a range, provides an estimate of a range of values that is likely to contain the true value of a population parameter, like the mean of proportion, based on sample data, right? So we're going to say, like, if we have this thing where we're measuring people's heights out of a population, we get a sample, we measure, and then we're going to get, based upon that sample, we'll get a mean. Here's the mean height. And we'll say that mean height is like 5 feet 10 inches. And then we'll say, and with 95% confidence, right, that, that's, it's like the people are going to be 5'8", plus or minus an inch and a half, right? So they might be so the mean of the population would be 5 feet, 8 inches, plus or minus, like, 1.23 inches, okay? And so this would be like our interval of estimates, and we say, hey, that's with 95% confidence, right? That this is like, that this sample point estimator, the sample statistic of the mean, the sample mean, with 95% confidence, right? That with this sample mean here, plus or minus 1.23 inches, I'm just making this up, these numbers, but that is going to, this range with 95% confidence, we could say that is going to contain the population parameter, the mean for the population. Okay, so that's kind of the game plan of what we're going for. And I'm going to copy all this, and I'm going to put it over here. I'm going to duplicate the slide, which means I got to go copy this stuff again, Control C, and I'm just going to delete everything that's in here, and I'm going to put all that there, and then I'm going to make it smaller, so we'll make it like 14, and it's really still pretty big. And so this can all come up to the top. Boom, and then we'll copy that, Control C, and to get it into the same place here, we'll delete this one, and then Control V, paste it. And then this one can all come up like this, and we can just put it right here so we have lots of room. And then we will still try to make it, I think that fits actually. So, and I don't know what it would look like if we did this all as bullets. Is that going to bring it in? That brings it in. So that looks good, and we'll get rid of this one, and we'll get rid of that one, and so we'll just do them like this, and so we'll move that one in, and we'll move that one in, and we'll move this one in, and we'll move this one in, and we'll move this one in, and we'll move that one in, and we'll get rid of these little marks that I had before. So there's our vocabulary, okay? And I like this vocabulary, and now that we did all that, we could actually bring this down a little bit because we don't need it till that, and then this one could come down to here. Where's that lock in? Right there. And it could come up. All right, we have plenty of room. So that's a little introduction to interval estimation, and we're learning these words here, like vocabulary, so that we could talk about this stuff. And that's those terms are really important for understanding this. And remember that when we get a sample of a population, the sample we get, if we're looking for like a certain characteristic such as the mean, and we're measuring the mean in our sample, we're getting a point estimator, right? And it's estimating the population parameter for the mean. The mean I don't know how you say that, but that's the idea. And based upon which elements we get in our sample, our mean could be different. And this takes us back to chapter 7 and even previous to that, where we start to get a sampling distribution. And that sampling distribution can be a normal distribution. We really try to go for that, and that's what we've seen. And then based upon that, we can look up our z-scores and things like that to start to get this range thing here, where we're doing stuff like that with a certain amount of confidence. We could say that our sample point estimator, our sample mean is this plus or minus a certain amount, and so with 95% confidence, our population parameter, the mean, is going to be somewhere plus or minus 1.23 inches on each side of 5 feet 8 inches. So that's the idea. That's what we're going to do. And the best way to understand this is to kind of hear what you just heard, and then also to actually see some examples. We're going to see all that in these lectures, and we're going to see how to do this when we know the standard deviation of our mean. And so remember, here we have our notation, and I'm done with this one here. So I'm going to get our notation. our notation, which I've downloaded, and we don't need these anymore. I uploaded those, and so here's the notation. I'm going to just open that in Paint because that's the easiest. You know what? I want to see what it looks like when we open with Photos, but I don't want to do Photoshop. Photoshop takes forever to open. That's even better. I like that. And so that's the notation for our standard deviation, and we're saying here that, hey, we know the population mean, or we want to find the population mean, do an interval estimate for the population mean, and we know the population standard deviation. That's the notation for population standard deviation, and then we want to have an estimate for our population mean, and we don't know the population standard deviation. And I know this is the population because that's lowercase sigma, and lowercase sigma is the notation for population standard deviation. And then we'll see how we could determine a sample size to kind of get the statistics to, you know, express what we want to express. And then we'll also kind of do the same thing with population proportion. So that's what's coming. That's your introduction. See you in the next videos.